Once again, good afternoon, everyone, and good evening. We will start with our second technical presentation. Hopefully, all of us are settled down. To introduce our technical speaker, may I call upon our chapter Professional Enhancement Director, Engineer Oliver O. Salazar.
Thank you, Engineer Lee. Good afternoon and good evening, fellow engineers. Now we will proceed to our second technical webinar, the Integrating 3D Modeling to Influence Design Decisions. Our technical speaker is a dedicated and passionate environmental professional. He focused his decade-long career in building services, engineering design, and energy modeling plus auditing. He have a wide gamut project, accomplishment from residential development, industrial and institutional facilities, high-rise commercial buildings, and mission-critical projects across North America, Southeast Asia, Middle East, United Kingdom, and Australia. He is graduated in Bachelor of Science in Mechanical Engineering at Mapua University, Manila, year 2005. He is member of Professional Engineering of Ontario, American Society of Heating, Refrigerating, and Air Conditioning, Chartered Institution of Building Services Engineering, Canada Green Building Council. His professional accreditation are LEED accredited professionals in building design plus construction, well accredited professionals, Whitwell Ambassador Center for Active Design, environmental professionals in training, energy and sustainability, chartered building engineer, ASEAN engineer, climate reality leader, citizen climate lobbyist. He is currently based in Canada as intermediate mechanical designer and energy modeling lead. Ladies and gentlemen, let us give him a round of applause, our second technical speaker, Engineer Glen Garcia.
Thank you, Engineer Oliver. Magandang umaga po sa inyo, magandang hapon po sa inyo dyan sa Saudi, and good evening po sa mga kasama po natin sa Pilipinas. Narinig niyo po ba ako?
Opo, sir.
Ayun, ayos. Malakas.
Clear, sir.
Loud and clear.
Claro em recto, sir.
Claro em recto. Sige, sir. Share ko yung screen ko para at least makita nyo yung aking presentation. So, nakikita nyo po ba?
Kita.
Okay. So, good morning. So ito po ang presentation ko regarding integrating energy modeling to influence design decision. So tulad ng mga nakaraang mga presentation ko, I usually start sa background ng aking presentation. So ito ay kinuha ko from Ray Dalio, yung Principles of Success niya na libro. So in every design and even in our life, meron tayong target and meron tayong mga goals and aims. And sometimes kahit na meron na gusto natin kunin yon, we struggle and we fail and we reflect on ourselves and also diagnose what's our design, and we redesign and design our targets until we reach our results or success. So ang agenda is first the introduction of energy modeling and energy design targets, kung ano po yung efforts and savings na dapat nating gawin. any design inputs and processes, singular analysis of single systems and holistic systems, and finally kung ano po yung case study na based on designing based on energy model. So pwede nyo po kung feel free po kung gusto nyo pong mag-message sa akin or mag-interrupt me kung may question po, or otherwise we can always go to the end of the or it's much better to go on the end of the presentation. So as designers, engineers, and architects po, we always do design and modeling sometimes, and like what the famous architect, U.S. Architect and designer said, Buckminster Fuller, the best way to predict the future is to design it. So every gadget or every building, we start to conceptualize and research and then also design it. So from nothing to something, we as engineers and professionals design something that would help us kung ano yung gusto nating gawin, either building or any gadgets. So just like what Buckminster Fuller said, para sa atin to predict kung ano yung magiging future natin, we have to design it. Okay. So like here, wala akong pasensya na, wala akong sample for Saudi Arabia, but this one is in Dubai. So from the desert of Dubai, it's a barren land, talagang disyerto lang, and sand, but because of design and also the forward thinking of people, for them to foresee kung ano yung gusto nila mangyari, so they started to design buildings. So from this desert or barren land, now it's a big metropolitan sky city kung saan meron tayo maraming skyscraper, mga roads and infrastructure. So that's the benefit of design. So same in Singapore kung saan dating fisherman village lang yan. Ngayon it's a big metropolitan city. So ano bang role natin as designers, engineers, and professionals? So dahil mahilig akong kunin ang quote ni Buckminster Fuller, so a designer is an emerging synthesis of artist, inventor, mechanic, objective economist, and evolutionary strategies. So there's a big role on us as a designer. So we do a lot of things, and we do a lot of forward thinking to get our goal. So like I said, the designer goal from barren land to a big casino. Kung sino man ang sa inyong gusto magsugal o gumala, then there's a lot of possibility in doing design. So if I go back here, let's say in doing design, right? There's a lot of importance in doing design. Like for example, this kind of building. So before you construct this building, we have to know what's the concept behind it, or is there any requirements on let's say either energy target. Lalo ngayon, it's very popular for us to not only design based on the functionality and usage ng building, but also to make sure that it's better for the environment, the community, that we're not emitting a lot of emissions, or we're not, this building would not consume a lot of energy for the stakeholders for them to save money. Kaya there's a lot of factors for us to do in designing this building, and even the rest of the buildings or the infrastructure. So one way for us to design is to do like CAD or Revit, like 3D model, for us to make sure that the building constructed is accurate and less, we will make less investment on like much of the steel or concrete, so we can save a lot of money in developing those, rather than saying so during construction we will say, okay, ano bang ginagawa mo? Wala lang, basta lang naglelay lang ako ng brick. Then it will probably take a lot of time and money and materials just to create, I don't know, a bunch of square houses. Pero kung meron kang actual design and meron kang blueprint sa plano or sa building na yun, then you can actually create a massive or a beautiful infrastructure like this, in like the one that we see in Las Vegas or Dubai or in Saudi as well, in Jeddah. So like I said, this is one of the ways for us to do the design, especially during the preliminary stage, is to do building energy modeling. So ang building energy modeling, like what I said in my previous presentation, it's a computer simulation where we simulate the building on virtual environment and test whatever systems. Let's say if we have an HVAC system, let's say VRF or VAV system or DOAS, or we have a lighting control or 70% glazing based on the architect, or any kind of building infiltration, if there's any, we can simulate that using the building energy modeling. So sa energy modeling, it's not only building that we can simulate, but also some of the effects of climate change. So meron akong sample dito on Metro Manila. So we can see that like based on the 2020 weather or climate in Manila, you can see this one from starting on this blue bell curve. So I've simulated the effects of climate change in Manila from 2020 up to 2050, and like medyo nerdy lang, and generated normal distribution curve. So kung mapansin nyo, ito yung curve, no? So from malamig, from let's say 20 degrees, pinakamalamig sa Manila, pero hindi siya nag-occur most of the time. So probably once lang. And then the typical normal temperature ng Maynila ay 27.5 degrees Celsius. And then ang pinakamainit is around, let's say 38 degrees in 2020. So fast forward in the future, you can see na yung curve nag-shift to the right, meaning from yung normal temperature natin from 27, ngayon 30 na in the future, kasi umiinit dahil sa climate change. And kung i-graph ko yung typical year sa Manila, so from 2020, So dati may malamig na temperature pa from 21 to 27 degrees during the morning, and some temperatures in the evening. And then on 2050, meron pa ring malamig in the morning, and some of the temperatures, especially sa tanghali, ay umiinit. Kung mapapansin nyo, medyo tumataas yung ano dito, yung bundok, no, dito or yung curve dito sa tanghali. And then in the year 2080, mapapansin nyo halos most of the time ay mainit na ang Maynila. So it gives you the indication on what will happen on the future sa Maynila, and also it gives you an idea on how we actually design things, on kung paano ba tayo magiging ready in the coming future, not only in the increase of temperature but also like high storm and floods. So it gives you a lot of indication on how you make sure that whatever you design today will be ready in the future. So like going back on the 3D energy modeling and 3D modeling, you can see that if you're designing a condominium or any kind of building infrastructure, you can check with the architect or the engineers, let's say, what's the effect of 70% window to wall ratio in the building, and what's the effect of orientation. So in doing energy modeling and constructing this virtually, you can definitely see the effects kung ano yung mas proper way for us to orient the building para to give you a proper daylighting for the occupants, or even have lower HVAC system inside the building. So we also indicate kung ano man yung actual architectural design ng building. So in the energy model, we have to make sure kung ano man yung different types of walls, like ito by concrete or curtain wall, and we have to know what's the thermal performance of each of the walls. And sa Saudi, sometimes we also consider the thermal bridging, especially during the winter, if or cold season. But sa Pilipinas, we normally don't consider the thermal bridge. Ang thermal bridge kasi, since we have like a couple of studs or any kind of cladding attachment, yung thermal performance ng envelope mo ay bumababa. So kung meron kang R20 na insulation, then dahil sa thermal bridging, yung R20 mo na nominal R value magiging R15 lang, effective dahil sa studs at cladding supports ng wall or roof. So sa energy model, we also study kung ano man yung air movement inside and outside the building. So sometimes we study kung what if we have natural ventilation or operational windows or any kind of openings inside the building, what's the effect inside the building. So we can do that manually, like all the energy model or like airflow analysis can be made by manual calculation or like engineering principles, but it will take you a long time for you to get that, rather than in subjecting that in the energy model. You can instantly see kung ano yung nangyayari sa loob ng building. Same with like I mentioned before, like lighting systems inside the building. So if you have a certain requirements on the lux level of the inside the room, or even if you're in New York, like what's the lighting load for the whole city. You can instantly see the effects inside inside the energy model. And let's say if you put different kind of light fixtures, what's the effect on energy for that building. Same with the occupancy. The good thing about the energy modeling is like you can have multiple occupancy in the building and see how the building load goes. Or let's say if you have a certain plant or building operation, and you can see that, let's say during the day you can see that the energy goes up, and during the night it's lower on a certain, let's say if you have a hotel project, then you can instantly see that in the energy model. And kung mapapansin mo, if you see that your energy is going up and you're penalized because of that, you can easily do some peak shaving analysis doing energy model. So there's a lot of good things to do in doing energy model, not only in energy, in natural gas quantification, but also to study the effects of occupancy. So itong favorite nating mga mechanical engineers, the HVAC portion and mechanical systems. So in the energy model, we can clearly define, let's say we have a BAB floor plan here, and we can easily put that in our energy model by creating this kind of systems, where it is a simple representation of our design, and check whether what's the airflow, what's the specific airflow for each of the rooms, which is specified here, and what's the like heating and cooling coil capacity, and the fan capacity, and fan power and static pressure of the system. So kung ano man yung na-design natin mechanically, we can also reflect that in the model. So eto malamang gusto ni Sir Lorenzo to. So sa PV, sa energy model, we can also determine kung ano man yung what's the best position and orientation ng mga photovoltaic in a building. So if you can see, hindi lahat ng location ng building ay pwedeng lagyan ng solar panel. And even if pwedeng lagyan, hindi mo malalaman kung effective ba yung solar panel o makakatanggap ba siya ng much photo sunlight from the sun. So in energy model, you can see the effects on how many hours you can have a solar access and at the specific location of your building. So on the energy target, so we have the energy model. Ano bang usage ng energy model? So we have a lot of usage in doing energy models. So this one is one example of the energy model that we developed. And what are the energy and design targets that we have? So minsan kahit sa Pilipinas or Saudi, let's say if you have lead, then, and even here sa Toronto, so we have to go with the 3 targets. So it's either code compliance for permits. So lalo dito sa Canada, each new building or major renovations required ang energy model. So that bago pa i-construct, alam nila kung ano yung energy performance ng building. The next target of the of design and energy model is the green building. So sa Pilipinas, kahit saan, we use like LEED, or sa Singapore like Green Mark. So we do energy model for the green rating system. And also, let's say client requirements. So the client, either Film Life in Philippines, Cebu, they have they want to shadow lead silver, and they have a certain specific energy target na imi-meet. And same here in Toronto, the University of Toronto, they have like they want to make sure that they are 40% better than what's specified under the ASHRAE 90.1. So we can start at aiming at those targets. So like on my previous presentation, I really like this curve. So this shows the degree of effort and potential savings. So like I said, you will always have a much larger savings in the earlier stage of our design and construction rather than at the later stage of construction. Because let's say during the design development, na-design mo na siya, lahat na nandyan, kumbaga lahat na ng equipment na select na, and then later the client said, oh, we have 30%, we wanted to have 30% energy reduction on our project, on our building, pero na-design mo na siya at a later stage. So you would have to make a lot of effort, like revising some of the equipment and probably ducting, and it's hard for us to change that at the later stage because the may expectation ng client and the architect, like for example, the size of the shaft, the opening, it's already there, and we can't change much of our equipment. So we'll have to make a lot of effort, and at the end, we might not meet the 30% energy reduction requirements by the client. So it's always important for us to specify to the client and to all the stakeholders in construction prior to design and construction na we have this much target for us to achieve the goal or to be successful in our project. So like I said, kung basta na lang tayo magbe-build ng building without any design, kahit man lang drawing or any energy target, it's like nakapikit tayo, lalagyan natin ng piring ang ating mata and then mag-shoot tayo. So in the end, hindi tayo makaka-shoot. Kaya kung sabihin nating merong energy targets, hindi natin ma-meet yun. And we would have to do a lot of redesign para lang ma-meet yun. And in the end, syempre, dahil magbabalik tayo sa conceptual stage and magre-redesign tayo, madi-delay tayo ngayon. And dahil may delay at maraming oras ang overtime and resources, then you have a lot of fee overruns. And in the end, we only have a compromise solution. So hindi natin na-satisfy kung ano yung requirement ng project, or kung ma-satisfy man natin, it's not on time and it's over budget. So we also do a lot of things in energy models. So let's say we run the energy model and we see kung ano yung energy consumption ng building in terms of lighting and in terms of humidification or heating, cooling, or lahat ng mechanical systems and lighting systems sa building, makikita natin, and even the effects of thermal performance ng building envelope natin. So like you can see here, so because this one is in Canada, so medyo half ng energy namin ay from the heating and we only have few from cooling. So we modify this and we diagnose. Let's say the architect said, oh, I wanted to have this much lighting savings. So from here, makikita namin na may 7%. So kung marireduce natin to ng like 3%, then it means that we can able to show the architects and the client na we can save much lighting energy based on this kind of technology, like typical LED. And then for the cooling system, you can see that on the upper ring. So we can break down the different kinds of contribution to cooling. Like for example, because we have poor glazing, so we only have like double glazed windows with solar heat gain coefficient of 0.45, which is napakataas. So you can see that the majority of the contribution sa cooling ay due to solar window. So you can see that, okay, so if we can improve the solar window, what can be the effect? So we calibrate those prior to design, and even here like lighting gain and outside air. So you can see that. So if we could put like demand control ventilation, ano bang effect? And same with the heating. You can see here on the heating, majority of the load is coming from the outside air, and based on the analysis, we can see that konti lang ang effect sa heating sa wall and roof and window conduction. So in design, we can see here based on the energy modeling results na, oh, we don't have to invest much on the building envelope because mayroon lang tayong 3 or 5% maximum na energy contribution from the load. But we do have to invest on the glazing because during the summertime where we need some cooling, there's a lot of impact on the solar window. So from this image, you can clearly see na ito pala yung mga pwede nating gawin o i-diagnose para ma-meet natin yung energy requirements or design requirements kung gusto nyong maka-reduce ng heating load or energy load or any kind of energy use sa building. So here it's lalo dito sa Canada, and it will be also important sa Saudi and even sa Pilipinas yung amount of energy emissions, carbon emissions and energy consumption kahit nga sa bahay natin, di ba? Kung makakatipid tayo ng kuryente, mas gugustuhin natin, di ba? Sa pagbabayad lang ng Meralco, napakamahal. Pero kung may improve natin yung system sa bahay and much more in the building, then you can save a lot of operational costs and also reduce greenhouse gas emission. So ito yung sample ng how we calculate the kilograms or tons of CO2. So once we calculate the kilowatt hour and cubic meter natural gas energy model, we just multiply that in the by the emission factor, and we will get that in the total tonnage or kilograms of CO2 per year. So same with the cost. You can see that once we have the result from the energy model multiplied by the consumption cost, like peso per kilowatt or reals per kilowatt, you can see kung magkano yung cost, yung consumption natin per month or per year. So kahit sa calibration ng existing building, so hindi ang energy model ay hindi lang applied for new buildings and major renovations. Kahit even existing buildings, like if we have an office building or residential building, then we will check first each of the monthly bills. Like, so monthly bills, what's the existing system inside the building, what's the probable thermal values for each of the building envelope, and then we graph that in either Excel spreadsheet, and we run our energy model. So you can see here, ito yung total energy consumption ng building, and kung ano man yung result ng aming energy model. So you can see that hindi siya perfecto dahil hindi naman lahat ng nasa energy model namin ay mare-reflect namin, tulad ng infiltration. So we would have to make sure na ang infiltration ay magagawa lang kami ng assumption. So hindi namin mare-reflect kahit yung actual building operation. But we can simulate that quite closely kung ano man yung aming assumption compared to the actual operation. So some requirements go to 5 to 10% na tolerance para kami maging off. Pero kung if you're more than 20% sa result mo, then you're way off sa actual building operation. So here lalo dito they're very strict sa what's the total energy per square meter ng energy mo for your design. So kung let's say ang requirement dito sa Canada or any specific country ay ang energy mo dapat ay 188 kilowatt hour per square meter lang. Kung lumagpas ka dyan, then yung building mo would not be approved for permit. So hindi mo mako-construct yan. Not unless you rectify the design and meet the energy requirements and the GHG emission requirements of the city or municipal city requirements or federal requirements sa energy. So it's very important for us na we do the energy model in the permit or even conceptual stage. So in doing the design and even energy model, we balance 3 things. Like in sustainability, lalo kung gumagawa ka ng lead projects, we have like the triple bottom line of sustainability, which is people, profits, and planet. So we balance those things. And same with the building, we balance ano bang energy consumption ng building, what's the energy cost of the building, kung magkano kinukonsumo ng building per year or per month, and anong ang greenhouse gas emission na ini-emit nito. So we balance those things because sometimes na we have lower GHG emission pero the operational cost and energies is high. Like for example, here ang greenhouse gas emission ng heating, lalo kung it's coming from the boiler where you use like natural gas or let's say coal, the greenhouse gas emission ng natural gas ay much higher than the electric. So sa electric hindi masyado ang greenhouse gas emission dito. Pero ang problema ay ang cost. Mas mataas ang energy consumption, energy cost per kilowatt ng electric kumpara sa natural gas. So we have to balance those things out in energy, make sure that what we design and what we model is practical. So ano bang design input and process during in developing design for buildings and energy model? So this one is a trickle down effect. So it started from the architects, from building geometry, specifying ano yung envelope, ano yung kung may shading devices ba na ginagawa, and ano yung mga window to wall ratio na gusto nila, especially in condominiums. Usually they like 70% or higher. And then it goes to like the mechanical system. Once we receive the architect's information, zoning, we develop the building nodes, specify the equipment, and efficiency. So same with the electrical. Let's say once we develop the mechanical system, the electrical engineers would check what's the lighting power, what's the equipment from the mechanical, and also once we develop those, then the mechanical and electrical, then we'll have we can able to determine what's the energy cost by conducting energy model and what's the energy use and greenhouse gas emission from that project. So you can see that this is a trickle down effect. Now, whatever the changes in the architect affect the mechanical, electrical, and even structural design. And also going to the horizontally, you can see that this one for us to improve our design and meet the target, each of the trade or discipline would have to first research, analyze, brainstorm, test the design that they have. Like let's say during the conceptual stage, yung mga architect, okay, what's the best way for us to have this kind of shape or building? Ano bang magandang orientation? So they strategize those things. Same with mechanical. So what's the best way for us to minimize the impact of the building load? So we do a lot of these things um, on a daily matter on our everyday activities. So how do we analyze our building system in the energy model? So for example, here in this graph, we can see that we have three types of sections. One is the passive energy conservation measures. So passive meaning for us here is mainly architectural or building facade and fenestration. So we analyze different solar heating coefficient and of windows and what's the R value of a certain wall. So we can see that at a different stage of or different types of walls, you can see the energy reduction. And also kung may itong green na to, kung meron kang BIPV sa building, then you can have like a small blimp of energy reduction. And here it's a behavioral energy conservation measure. Uh, behavioral energy conservation measure is about controls. Let's say if you have demand control ventilation or like smart thermostat, lalo ngayon kahit sa home, meron tayong mga parang Alexa or like control integrated system sa bahay and even sa building. So it reduces either your heating energy because especially on demand control ventilation. So depending on the CO2 concentration or schedule, you can modify the airflow of the outside air and therefore like reduce the amount of heating energy and cooling energy. And same with the lighting if necessary. And finally, the mechanical energy conservation measure by applying, let's say, heat recovery or high efficiency chillers or district heating or cooling, which have higher coefficients of performance compared to like on-site equipment. So we can definitely see the effects on the energy model by and graph the individual effects of each system. So ano ba yung holistic measures? So let's say you can see we have a baseline. Usually ang baseline ay there's a specific code requirements kung ano man yung dapat mong ilagay sa building as a baseline or kung ano man yung existing operation ng building, lalo kung ang client may existing building and client wants to save money, then you would have to like I said here, this is an existing building. So kung ano man yung operation ng building at na-match namin yung energy consumption sa energy model, that would serve as a baseline in our building. So let's say we can set up different energy conservation measures here. Let's say in-improve namin yung envelope. Ito yung energy consumption and energy reduction. And individually, in-improve lang namin yung lighting dito sa building na ito. So you can see that there's a huge reduction on lighting. And finally, we just improve here the mechanical portion ng building. You can see that there's a huge reduction on the heating and cooling system. So if we combine this individual energy conservation measures, anong effect? So there's a synergistic effect. So once we combine this and simulate that, you can see that based on the combination of these three cases, you can see that there's a large energy reduction of energy. So compare from the baseline, you can see that the baseline have this much energy, like 4.5 million kilowatt hours. And now based on applying these three measures in a holistic sense, then you can see that it reduces to around 2 million. So from 4.7 million to 2 million kilowatt hours. So you can see how much energy did you reduce and how much energy cost did you reduce by applying the energy conservation measure. And that is done in the energy model. So prior to construction, you can see that, okay, by doing this is the probable effect of the system. So going to the actual case study, so this was done in Toronto. So the client wants to know what's the effect of this. So he wanted to know what's the advantage and disadvantages of the two system, which is the natural gas boiler, yung typical na design natin, or the ground source heat pump sa building na ito. So you can see hydronic boilers have a high energy consumption, and because yung ground source heat pump, it has a higher efficiency, so you can see mababa lang ang energy consumption. So just looking at this, you can see, oh, so maganda pala ang ground source heat pump. But also, like I said, on the three graphs here, it's not just about energy. It's also about energy cost and GHG emission. So you can see on energy, wow, maganda pala ang ground source heat pump. But if we go to the energy cost, dahil mahal ang kuryente, at ang ground source heat pump ay gumagamit ng electricity more than the hydronic boiler, you can see the hydronic boiler energy cost per year is much lower than the ground source heat pump. And if you're looking at the environment, ano bang carbon emission ng hydronic boiler, you can see that it has much higher hydronic carbon emission than electric. So as a stakeholder, ano bang mas mahalaga sa'yo? Mahalaga ba sa'yo, especially if you want to market yourself or your project as environmental friendly, ano ba ang pipiliin mo based sa dalawang ito? Pero it doesn't mean that this is the final system that na pipiliin mo, yung dalawa lang. We can either have a hybrid system that could match or take the positive impact of each of the system, or even create a newer one just to balance out yung energy consumption, yung energy cost, and carbon emission. So for this example, we only have two systems, but we can further develop this in other way by having multiple heating and cooling system proposal. So other case studies are this is doing building permit in a restaurant. There's a restaurant in a ground floor and a two-story floors for offices. So it's like a mixed use. So ito yung characteristics ng building, like it's located in Toronto, and the NECB is our National Energy Building Code. It's like ASHRAE or LEED standard here in in Canada, and they specify um, the uh, the architectural thermal performance and even what's the proposed mechanical system. Like same in ASHRAE 90.1, whatever your proposed building, the ASHRAE 90.1 would select the baseline energy system out of your proposed system. So since we have an RTU, the baseline selection here is to have a makeup air unit with RTU as well, and they have a specific performance in the building. Like for cooling, it should have 3.5 kilowatt, 3.5 COP. Furnace should be 80. Lighting power consumption, so whatever the airflow of that fan, so the power divided by whatever the airflow of that fan. So that's the fan power limitation that we have. And all of these building characteristics on our proposed design, it should be either equal or better for us to know whether the building complies for permit. So you can see when we run these information in our energy model, you can see that there's a huge reduction on energy. Like we achieve 15% energy reduction on energy, and we can see that the space heating, space cooling, though here in the space cooling we increase because of the glazing that we have, and yeah, and the overall window ratio of our building is much higher because the maximum window wall ratio of the reference or the baseline building for any CB is maximum is 40%. So, and what's the effect of carbon emission for each of the project? You can see that based on running the energy emission, the energy model, you can see that the carbon emission had been reduced by 9.6%. So you can see that by doing energy modeling, you can instantly see what's the probable effects of energy energy cost and carbon emission for each of the project. So that's it. So you can see that once you achieve that, you can achieve the goal, or you can have a successful project. Maraming salamat po. Thank you.
Thank you, Engineer Ace. Is there any question from our participants? Any other question? Any question? Are you still with us? Wala akong nag-reply, ano? Ako na lang po magtatanong, Engineer Ace. Is there any free software po para magamit namin? Katulad sa mga na-present. Or we have to rely on a consultant?
Marami pong software that we can use, sir, lalo sa energy model. One is eQuest. So it's a free energy modeling tool that we can use also, and it's approved as a approved energy modeling software here in US and Canada, and even for LEED it's still approved. So this one, and the other one is the Energy Plus.
Mm-hmm.
So this one is a free tool for us to develop the energy model. One thing I'm using now is not Energy Plus, but also but IES. So this is one of my favorite energy modeling tool, kasi not all energy modeling software are created equal. So there's some limitations for each of the energy modeling software. But the most advanced and the most interactive software na nagamit ko for energy modeling is IES.
Pwede mo pang i-type yan po dito sa chat box natin. Para
Sure,
po
sir.
reference na lahat. And then we have the next question coming from Engineer Danilo Vihersio. How far is the
Hi, Sir Danny.
Philippines percentage in implementing fully the rules and regulations of other countries? Maybe you have an idea for this, Engineer Ace?
That's actually a good question, Sir Danny. To be honest, there is some effort by the government to save some to implement these in the Philippines, like some kind of incentives. Pero unlike here in developed countries, we can get more incentives from the government, unlike in the Philippines. The only thing that I'm currently seeing now in the Philippines, with respect to implementing these measures, is more on the private companies or private projects. So I only saw like few government projects and government programs in energy conservation measures on energy, but most of the time it's being done by private individuals or companies. So I hope in the future, depending on the government or government body, that we can also commit to making these measures mandatory. Kasi like for example in the Philippines, once we construct building, we don't usually care much on energy, as long as you have the design, you have the blueprint, and you submitted that in the municipal or any kind of government entity. They will approve that as long as you meet the design criteria. But when it comes to like energy consumption, kailangan ganito yung dapat yung GHG emission, so far wala pa. It's more on like lead project in the Philippines. So if the client wants to market that their building is lead gold or lead platinum, then they would implement those measures.
I believe it's clear. And the next question is coming from Engineer Jordan Dial. How about trainings and certifications?
Thank you, sir, for the question. Trainings, there's a lot of trainings online, especially like IS. They do give like training face-to-face or online. So you can definitely see the trainings that they have here. And there's some also other online training that you can see just by Googling, like energy modeling training. You can definitely see those. In Middle East, I saw one in Dubai, and that they also conduct trainings, and I haven't seen one in Saudi, but in Dubai and Philippines, especially in the Philippines, they conduct like a much affordable version of the training compared to other countries. So there's a big advantage for us in the Philippines. So for certification, so far, ang certification sa energy modeling is mostly in UK. If you are providing like energy certificates, you have to be certified. But here in North America, you can either be ASHRAE's BEMP or Building Energy Modeling Professional. So you can once you pass those, then it gives you the credential that you had been certified by ASHRAE as the energy modeling professional. So that's it, sir.
Thank you, Engineer Ace. And for the last question coming from Architect Clemente Bligat-Boton. How do you bill your clients? As per building volume or in energy reduction parameters?
That's a good question, sir. So there's certain ways depending on the contract, sir. We have one project in Kazakhstan where the building have a lot of it's quite massive in area and size that the our company decided that whatever the percentage reduction that we have reduced compared to the baseline, let's say we have this 40% energy cost savings that we have. So let's say the building operation is uh, operating annually at $90 million, right? So if we reduce that by, let's say, 50% or 40%, then we can save like $45 million per year. And once we save that amount of money from the client, we have we can ask, okay, whatever you save on whatever we save based on our energy measures, let's say 45 million, 20% of that would be our our fee. So that's a lot of money by doing that. And even here, some of the projects are like, for example, we have housing projects or building projects. How we bill the client on doing the energy model by the amount of hours or time we develop the model and the report. So whatever, let's say, um, if typical amount of hours we develop is let's say around 50 hours or 120 hours in depending on the size and complexity of the project, then we will bill you based on the amount of hours.
Okay, it's clear. Yes, I think, thank you, Engineer Ace. I think that will end the question and answer portion. And let's move to the awarding of plaque of appreciation. I would like to call upon our conference chairman, Engineer Lorenzo Godbiola, to present the award.
Thank you, Engineer Lee. Let me read the contents. We present this plaque of appreciation to Ace Glen Garcia, EIT, Lead AP BD plus C, Well AP, Mechanical Designer and Energy Modeling Lead, Mat 4 Site Engineers, Toronto, Canada. In grateful recognition and profound appreciation of his unselfish dedication, support, and invaluable contribution for being the technical presenter on integrating energy modeling to influence design decision. During the chapter's 2020 virtual mid-year general membership conference, given this day of August 2020, via virtual conferencing, duly signed by our Aldrin Alison D. Lango, ME Chapter President, Lorenzo Gabiola, ME Conference Chairman, and Jose Melvin D. Santos, ME Chapter Secretary. Sir Ace.
Thank you, Sir Lauren. Thank you, PSME and everyone for this plaque of appreciation. Thank you very much po.
Our sincerest gratitude for your usual support in sharing your expertise, especially in today's virtual mid-year conference. We hope in the future we could ask you on how to follow your footsteps.